Hello, everyone. Happy Friday. Thank you so much for coming to my talk. I know it's a tough moment right now between Nelson's talk on Gradle caching in the other room and just 1 hour away from the famous lasagna. I'm not sure if it's still lasagna, but hang in there. Today we will talk about various ways of doing mobile authentication on Android. My name is Emma Tresanszki, and I work in JP Morgan Chase UK. My background is a funky combination of finance, cloud communications, 2FA, also augmented reality in 3D mapping. So today, we will talk about how does the user authenticate in your application. Validating user identity is incredibly important in mobile apps. These days, most people in the world own a mobile phone, and developers are commonly using numbers as an identifier for users of their services. Now, one of the most common approaches to this are social login by using the mobile phone number, and then for subsequent checks, using biometrics. But there are many more, and this is what we will be exploring today. We won't be talking about biometrics, though, because that's something most commonly used for subsequent logins. So what we will cover today, mobile authentication based on the phone number with traditional methods using 3D third-party services such as Nexmo, Twilio, if you heard about them, and also Firebase, to name a few. Also SMS verification APIs. You can actually improve the onboarding time by using APIs like Google's SMS verification API. They really come in handy. And then Firebase authentication. That allows users to sign in into the application using either email, password, phone number, and federated identities such as Google, Facebook, Twitter. This Firebase auth, if I'm sure you know about it, is a complete solution because they provide also backend services, easy-to-use SDKs, but also pre-built UI libraries, which makes implementation easy and simple for devs. And then we have social logins. Again, they're very common, but we will weigh the pros and cons depending on the use case. Would you, for instance, rely on social login to access your bank account or to perform a transaction? I'm not so sure. Next, in terms of using SMS for phone number verification, are there any flaws to consider when relying on OTP to be delivered via SMS? Would user actually drop off during onboarding because of low SMS delivery rates? And then what about security? Is there any flaws to consider when using SMS? Do you think that your app may be vulnerable to SIM fraud? And what does SIM fraud actually mean? And then lastly, but not least, we will also explore a newer approach called number verify. So that's authentication based on the SIM card that can confirm the ownership of a phone number without relying on the OTP. Yeah, you heard that right. There is no SMS involved in this solution. So let's see. User identity. I'm curious to see what most of you here rely for user authentication and if you're happy with the verification methods adopted in your project. And what is the user drop-off, like the user drop-off percentage, if any, during onboarding, in case the SMS messages are too long to be delivered or don't even arrive at all. So how does it work? How do you do phone number authentication? There are a variety of ways of verifying phone numbers, but a randomly generated one-time password, the OTP, sent by SMS is one of the most common. Sending this back to the developer server demonstrates control of the phone number. So what is the OTP? Is just a 3 to 6 digit code that is used to authenticate a user to complete just one task or one transaction. Where is it used? It's often used in two-factor authentication, 2FA, in order to provide an extra layer of security for the user when he tries to log in to a service or to perform a single transaction. Does it expire? How long does it stay valid for? Well, it's only valid for a short amount of time, so after the validity period is over, you will have to call for a new OTP. And there we also have voice OTP. So in some situations, you might get a phone call that enunciates the OTP for you. This verification is done by making a call to the mobile number and playing a sequence of digits. And in order to verify the phone number, the user needs to confirm the played sequence of digits. So there are plenty of APIs available on the market for doing 2FA. You have APIs such as Nextmo, Twilio, Telesign, just to name a few. You also have complete solutions like Firebase Authentication. But how does it really work when you should receive an OTP? Is there someone on the other end manually inserting the OTP into the system, and then that is manually typed as an SMS? Well, not at all, and this is why these companies provide APIs for cloud communication. So let's just see a basic authentication flow. So first, you start verifying your phone number. An API will send you the OTP. You get the OTP via SMS. The user inputs the OTP into the app, and if all goes well, your number is verified, right? So how long can it take between each step? Well, it varies, but let's examine. Let's see here, first step. User enters the phone number. So you have the user either manually entering the phone number or the application reading the phone number for you. Well, this is more or less easy to achieve on Android, right? But it doesn't actually always work if your number was ported, for instance. You also need additional permissions that can be rejected at any point at runtime. And also, you rely on this class on the telephony services to read the phone number. I have even seen variations on Stack Overflow where you need to check against the length of the number. You perform various operations on the string in order to remove some parts of the number. There is also this subscription manager that adds support for using more than one SIM card at a time. So they let you query phone numbers for more than one SIM card. But that was a long time ago. Luckily, now we have APIs such as from Google Play services that can read the phone number more reliably. So you can obtain the phone number in whichever way is more appropriate for your app. Often the best user experience is to rely on the hint picker to prompt the user to choose from available numbers. So to use the hint picker, this is just a short example. You just construct a request, a hint request for phone numbers, and then you show the picker, and then you simply use a pending intent for that. And then simply you obtain the phone number from the result. Okay, but before you continue, let's pause a bit to talk about the evolution of phone numbers. So one of the first telephones was revealed in the world in the late 1800s by Bell. The communication systems did not work with traditional phone numbers, but rather with a system where all calls were routed on the same line through switchboard operators, these very nice ladies over there. Telephones were sold in pairs and needed a crank to operate electricity, which could cause the other phone to ring. Eventually, users would call the operator, give them the name they were trying to reach, and then be connected manually. Operators were localized, so they would personally know everyone that they were speaking to. Just a couple of years later, in Massachusetts, there was a measles pandemic in America, and it started to infect citizens in the town. So citizens were being quarantined to minimize the spread. This sounds too familiar right now, including the 4 switchboard operators in the town. So if the switchboard operators were to get sick, no one would operate the town's telephone system. So someone suggested that the 200 phone users in the town would be assigned the number. This would mean that anyone could be trained to use the system without personally knowing the families. And the first phone numbers were only 1, 2, or 3 digits. This form of identification was quickly adopted across all North America, and fast forward in the 1900s, direct dialing became accessible. This would mean you could call numbers without an operator's need. So phone numbers had evolved since to include an exchange for the identifier for the geographical area, and users could call these numbers and be directly connected to the other end. And since then, we've seen technology advance at rapid speed, including toll-free dialing, call waiting, speed dial, and many more. So phone number. The phone number consists of four parts, sorry. You have the country code, which is pretty self-explanatory. It's a numerical identifier for a geographical location used at the start of the number. These numbers range from 1 to 3 digits. And for instance, in North America, you have the country code 1. When dialing a number, if it's a long-distance call, you normally include the 1 before the rest of the number. The second part is an area code. These numbers are assigned based on a larger geographical location within a country. So in Canada, for instance, these codes are assigned based on the province or largely populated cities. But smaller provinces like Nova Scotia may have only 1 or 2 area codes, while Ontario has more than 10. And then the third part is the exchange number or a prefix. This used to be a way to identify an even more localized area. And then lastly, we have the line number. These 4 numbers are randomly assigned and unique to each phone number. And while it used to be possible to select your own 4 numbers, now it's harder to find a unique sequence. Long gone are the days where you could choose a number to represent your birthday or name, but instead, these numbers are now randomly assigned. So let's just see a few falsehoods that programmers believe about phone numbers. First, phone numbers cannot be reused. Actually, old phone numbers are recycled and get reassigned to other people. Phone numbers that are valid today will always be valid, and phone numbers of a certain type, for instance mobile, will never be reassigned to another type. But actually, a phone number which connects today can be disconnected tomorrow, and a number that is free to call today may cost money to call tomorrow. So, because the phone company may even decide to expand the range of available phone numbers by inserting a digit into an existing number. 3, each country calling code represents exactly 1 country. No, the USA, Canada, and several Caribbean islands share the same country code, +1, for instance. Also, Russia and Kazakhstan share +7, and these are not the only examples. Each country has only 1 country calling code. Well, phones in disputed territories or partially recognized states, such as Kosovo, for instance, may be reached by dialing the country code for Serbia, Slovenia, or Monaco, depending on where and when one obtained the number. And the next one, to make a number dialable, you only need to change the prefix. This is not really true because, for instance, in Argentina, to dial a phone number domestically, you need to input these digits 15 after the area code, but before the local number. And you also need to add digit 9 after the country code. Actually, you need to remove it, so this transforms the first number into the second one. Just a few more examples. And a valid number will not reach an invalid number will not reach an endpoint. Well, in some countries or in some phones, extra digits may be thrown away. So if you call 1-800-Microsoft, which is an invalid number, it can still connect to Microsoft. Numbers such as 911 can be reached by dialing 911-123 in some countries, but not in others. Then all valid phone numbers follow the International Telecommunication Union specification. So this ITU specifies that a phone number cannot be longer than 15 digits, with 1 to 3 digits reserved for the country code. But actually, phone numbers in Germany have been assigned that are longer than this. I mean, it's not a surprise, even the numbers are long, not only words. 8, all valid phone numbers belong to a country. Well, actually, there are many country call-it codes used for non-geographical entities, such as satellite services and the 800 code, which is used for free phone numbers, which is just toll-free numbers. And then phone numbers contain only digits. That is false because, for instance, in Israel, certain advertising numbers start with a star. In New Zealand, non-urgent traffic incidents can be reported by dialing *555. Also, alpha characters may be used in phone numbers, such as 1-800-Flowers. And then 10. The plus in front of phone numbers in international format is optional or can always be replaced by 00. Well, this 00 is a common international prefix, but it actually varies by country. Because in North America, while you have the country code +1, you can also drop the plus in front of the number and just write it as 1555. And to call this number from Japan, when the international prefix is 010, you can also call it like this, 0101. And then the last one is that phone numbers are just numbers. This is not true, so never try to store phone numbers as an int or any other kind of numeric data type, because you cannot do arithmetic on them, and while 007, 07, or 7 are the same number, they don't necessarily mean they're the same phone number. And in some countries, a leading 0 is significant, and in some countries, it's not. So after hearing all of this, would you still want to let the user input their phone number? If you need to handle manually filled in phone numbers, you should use libraries like lib phone number, for instance, to parse and format numbers and to handle them correctly for each country. We're going to see it here. So this library, lib phone number, is a third-party library, and it's an open source one. Can be used to validate that the number is correctly and extract it properly. So it already handles all of these special cases described in the previous slides. So you don't need to handle the number yourself, and you also don't need to make any assumptions. And we haven't even talked about the country picker implementation, where you choose the country prefix. Is there any widget for it? I guess there can be an entire talk based on this. But if you so wish to let the user input the phone number, there are tons of open source libraries that you can look for in Android Arsenal, such as this one in this example. So this gives you out-of-the-box UI components for country picker, search facility, autocomplete, and so on. Okay, so we can now resume the flow of 2FA. So step 2. After we obtain the phone number, we reach this step 2. So you have received the SMS with the PIN code. The user either memorizes the OTP, copy-pastes it to the clipboard, or you might even use something like SMS API in order to read it from the inbox. All you have to do is use the SMS retriever by calling this start SMS retriever function. And now you're ready to verify the user's phone number and get an instance of this SMS retriever client and attach all the callback, success, failure on the SMS retrieval task. And this task will listen for up to 5 minutes for an SMS message, and also this SMS message also contains a unique string that identifies your app, and we will see that in a bit. And then at step 3, yes, the user enters the PIN, or it gets automatically filled in by the system. And then at the last step, that the OTP is filled in, we wait for it to be verified on the other end, and that's it. Let's just see what happens behind the scenes if you're using any cloud communications API for doing phone number verification, or even for sending SMS, such as in this example we have Nextbo. So you have an API that communicates with your platform. And then the platform, the vendor, talks with the network carrier, and they have an agreement in place based on the geographical location. And then the carrier sends the SMS to your phone number. There is also a DLR, which is a delivery receipt. That's a feature that acknowledges the receipt of the SMS in downstream systems, and sometimes even the receipt of the SMS on the headset, if the corresponding carrier sends acknowledgement of receipt, but not every country does this. And in the next slides, we will see what can this entail from a developer's perspective. So as we said, there are many libraries for doing efficient phone number authentication. You also have Firebase phone authentication. But if you are an advanced developer and you need to build this functionality yourself, Google Play Services has 2 APIs for that in order to help you obtain the phone number and to verify it using SMS without the need for any additional device permissions. So you have the phone selector and the SMS retriever. With this SMS retriever API, you can perform SMS-based user verification in your app automatically without requiring the user to manually type verification codes and without requiring any additional application permissions. So you have here on the left at step 2, the user initiates SMS verification in your app. Your app might even prompt the user to provide the phone number or just use the hint selector that we previously seen. Then step 2, your app makes the request to your server in order to start the verification process. Depending on what information is available on your user database, this request might include the user ID, user's phone number, or both. And then at the same time, your application calls the SMS retriever API in order to begin listening for an SMS response from your server. And then we move on to the right-hand side. Your server sends an SMS message to the user. That includes a one-time passcode, the OTP, that will be sent back to your server, plus a hash that identifies your app. And when the user device receives the SMS message, Google Play services will use this application hash, to determine that the message is intended for your app and makes the message text available to your app through the SMS retriever API. And then your app parses out the one-time code from the message text, and it sends it back to your backend. And then your server receives the one-time password from your app, it verifies it, and then finally records that the user has successfully verified their account. Well, here we have some bits of the code involved. I won't go through it all, but you mainly have the phone selector, which is that hint picker. So the first step is to have the user initiate the SMS verification from within the app. Your app might prompt the user to use the phone, to enter the phone number, or you can use the phone selector to make this easier, using code like that. And also the SMS verification API gives the ability for the app to listen for any incoming SMS, from which it can parse the code automatically for you. So to get you started, your application just instantiates this SMS retriever client, and you do a start SMS retriever function, and just wait for the callback, either success or failure. So as we said, this OTP can be any string. You can simply generate a number, but the message needs to end with a hash that is determined using the app certificate. So Google Play services will use this hash in order to determine which app the verification message is for. You only need to generate this hash once for your app package and using the signing certificate of your application. This won't change over time and shouldn't be supplied by the client app at all. And then the server can send a message to the phone number using any existing SMS infrastructure or any service. When the message is received, Google Play services will broadcast an intent that contains the text of this message. So, and from here, you can just parse out the verification code and send it back to your server. So then you can finally confirm the phone number ownership. Okay, so that might seem like a lot, right? So let's see how can you do this via social logins. Because there are plenty of alternatives available. You can either ask the user to authenticate using their social media accounts, and this will guarantee that the user has been already verified, and most probably it's a legit user. Social logins, they allow for third-party applications to authenticate using the credentials from popular social networks, such as Facebook, Google, Twitter. So in other words, rather than forcing users to create a new profile, remember a new password, or fill in all the required details, you can just point them to the login screen of your selected provider. And after a successful verification step, we can get all the needed details from that provider. That's easier for users and also easier for developers, a combination rarely seen in software development. As we said, almost every major social network provider provides an API to allow application developers to authenticate users within their system. For instance, here with sign in with Google, you can provide seamless authentication flow for your user with one-tap sign-in. They call it one-tap sign-in, and also sign-up APIs. How does it work? You have here an example. So the application builds a Google sign-in client object. They specify the signing options it needs. And in this case, we selected default sign-in. Then, when the user signs in with the Google button that is clicked there on the left, the application starts the sign-in intent that prompts the user to sign in with a Google account. That sounds simple, right? So let's see how does this work with Firebase authentication, because that's a very complete solution. You also have Firebase UI. That's an open source library that they offer customized UI bindings on top of the core Firebase SDK. And it actually aims to eliminate a lot of boilerplate code and promotes best practices for UX and security. So Firebase authentication provides us with a collection of utilities that can make it easier to implement UI components within your application. So for example, you just need to begin by declaring the supported methods of authentication. In this example, we have email, phone, Google, Twitter, and Facebook. And once you have decided the authentication methods which are to be accepted by your application, you can create a list of them ready to use from within the Firebase UI builder. That looks something like this. So Firebase will show a button for each of these methods within the launched authentication screen. So of course, before attempting to do any of this, you need to be sure to enable all of these authentication providers from within the Firebase console, but we won't go through all the steps here. And for triggering the authentication flow, the Firebase authentication UI library, it contains a simple activity that handles the authentication process for us. So this means we have to A, listen for this activity, and B, just listen for the result that is returned by using our unique request code. Like simply return request code, as you normally would for when you start an activity. So for this, we'll just make use of this create signing intent builder from the AuthUI instance. And this will be triggering the intent when our desired button on the left is pressed. What else can you use Firebase authentication for? You can actually use it to sign in a user by sending an SMS as well. The user signs in using the OTP containing the SMS message, and then to sign in the users by SMS, you must first enable the phone number sign-in method in the Firebase console project. To use phone number authentication, Firebase must be able to verify the phone number sign-in requests coming from your app. And there are two ways in which Firebase authentication accomplishes this, via safety net and CAPTCHA challenge verification. We won't go through that now, but I just wanted to mention it. And when you send a verification code, legal requirements vary, but as a best practice and to set expectations for the users, you should inform them that if they use phone sign-in, that they must receive an SMS message for the verification. And then simply you just have the callback, in this case on verification completed, that is returned in two situations. So first, either in case of instant verification, because in some cases the phone number can be instantly verified without needing to send or enter a verification code. And then the second part could be auto retrieval, because on some devices, Google Play services can automatically detect the incoming SMS and perform verification behind the scenes without user interaction. But this capability may be unavailable with some carriers. So all of this code uses the SMS retriever API that we just discussed. It includes an 11-character hash at the end of the SMS message. And in either case, if the user's phone number has been verified successfully, you can use this phone auth credential object that is passed to the callback, and then just sign in the user, as we see here. So to continue the sign-in flow, we just pass the phone auth credential object to Firebase auth in order to do sign-in with credentials. And this is pretty much it. I've shown you all the most important bits, but there are many examples available online. And in case you were wondering, by the way, Firebase phone authentication is not completely free, but it does provide, I think, 10K free SMS verifications per month. Then what about do you think there are any security concerns associated with mobile authentication using the phone number? Actually, this is a quote from official Firebase documentation. So, authentication using only a phone number, while convenient, is less secure than the other available methods because the possession of a phone number can be easily transferred between users, but also because on devices with multiple user profiles, any user that can receive SMS messages can sign in into account using the device phone number. And if you use phone number-based sign-in in your application, they advise that you should offer it alongside more secure sign-in methods and also inform the users of the security trade-offs of using phone number sign-in. So let's talk a bit in more detail about all these security concerns. So what are the security concerns associated to SMS? Well, SMS can be spoofed, numbers can be recycled, numbers can be reassigned. And also the current process creates a lot of frictions for the users because finding an OTP with an SMS message and copy-pasting it into the form is cumbersome, and it can also lower conversion rates in critical user journeys. Also, attackers can spoof SMSs, and they can hijack a person's phone number. Carriers can also recycle phone numbers and then to new users after an account is closed. So while SMS one-time password is useful to verify a phone number for the use cases above, it is recommended to use additional and stronger methods of authentication. So I guess we all had to experience waiting for 5 minutes for the SMS that never arrives. And there's a reason for which every service has to provide the option to send the code again, right? And this does add a major friction to the user experience. And it is known that around 20–30% of the users drop off during the mobile onboarding process. And this number could even rise to over 50 when a second attempt is needed. How does this look like in practice? Well, it depends. So you might be lucky if Tom, let's say Tom is on network A. SMSC stands for Short Message Service Center. It's a network element in the mobile network that is sending SMS. So in this case, if Tom is on network A and then is on network B, it might go super easy, just from network A to network B. But what if the message wasn't sent by a person, but via an API? That is almost always the case with 2FA. So there can be more steps involved. So let's say the API server is in New York, that needs to talk to network C in Canada, but then that API server has a deal with network A in the UK, and then maybe even that network has a preferential agreement with network B that finally reaches Dan's phone. But if one of these carriers is unavailable or very busy, it can get even more complex, and it can take a lot of time. So the SMS will be sent to an aggregator, which picks up the message and sends it to the next SMSC. Okay, that was about latency, but what about security? So what about SIM swap fraud? Have you ever heard of SIM swap fraud? So just imagine this. A fraudster goes to Vodafone and tells them that they lost their phone and they want a new SIM card with the same phone number. So what the fraudster will do, they will just be profiling the victim. It begins with profile building. They collect exhaustive information about the target, maybe even from social media accounts. This can include personally identifying information, PII, such as the target's phone number or email address. The next step is pulling off the swap. So they will ask for a new SIM card to be shipped to their address, claiming they moved, or they would just ask for another SIM card. And then they get to making a profit. So when the SIM swap is completed, the damage is almost instant because the target's phone number loses signal, and their phone number will now connect incoming SMS messages and phone calls to the fraudster's new SIM card. So how does this let them steal the target's money and identity? To get this far, the fraudster is already equipped with enough socially engineered info to get the target's email address, username, and likely security answers. And now they can work quickly to trigger password reset codes for the victim's email, receive them on the SIM swap phone, and change the victim's credentials before they notice anything amiss. And if the victim's accounts are protected with SMS or phone call-based 2FA, there is no problem because the fraudster will receive these too. Just gaining access to the victim's email address unlocks all sorts of other online accounts, for instance, cryptocurrency, wallets, or other financial apps. So this means that all messages and calls meant for the target's phone number are now rerouted to the attacker, who then swiftly triggers SMS-based security to break into financial accounts or reset password before the victim can take any action. Pretty scary, no? I want to tell you about something new now, and I find this particularly exciting because I have worked previously with 2FA solutions myself. So mobile network operators in the UK, including EE, O2, Three, Vodafone, collaborated in order to launch a new system that is called Number Verify. So this system it's a new customer safety solution that aims to make it both easy and more secure to authenticate users' identity for online transactions. At present, a lot of online transactions, for instance, logging into a website or your bank account, includes a system that attempts to verify users, which is often 2FA, by sending the OTP password to the customer's phone number. This number verify technology may be new to the UK, but it has been already offered, by instance, in the US. So we'll see a bit on this right now. So how does it work? What is the idea behind it? We can confirm the ownership of a mobile phone number by verifying the possession of an active SIM card. Let me repeat. So you confirm the ownership of a phone number by verifying the possession of an active SIM card. One way to think about it is that you don't need to log in, right now, you don't need to log into your mobile network to use its services, right? You make a phone call, you send a text, you browse BBC News or ASOS or use your banking app. The reason you don't do this is that the mobile network is already talking to your SIM all the time and authenticating you, the SIM card, that you are who you say you are and have rights and permission to use these services. Of course, we don't notice any of this because it all happens all the time behind the scenes and it's seamless. And this is how a mobile network works, actually. So what the mobile industry is now offering is for service providers to benefit from this same no need to log in mobile network capability. And this company, TrueID, is one of the providers that enable us developers to use number verify technology. So how does this work behind the scenes? It might look complicated, but it actually isn't. So in a nutshell, you have here a URL-based check. All you have to do is open a mobile data session that is created to a unique check URL. So that's just created for the purpose of this verification. And then the system, the provider, TrueID, resolves a match between the phone number and the mobile network operator. So the mobile network operator identifies you as the owner of your mobile data session. So all we have to do from a user's point of view is that we have to request the URL on the mobile device over mobile data. So let's break it down here super fast. Again, all of these steps are seamless for the user, but what happens behind the scenes is that you get the user's phone number, like in any system, and then you send the phone number to your application server. And then behind the scenes, there is an object created, a subscriber check. And this object actually contains the actual check URL, and this is sent back to the mobile device. And then what you have to do is you have to return this check URL to the actual mobile device and just create a mobile data session on that URL. And you don't even need to open the browser. The user doesn't have to see that. You just create a data session with that URL. So after the request is performed, mobile device requests a subscriber check result via the application server, and then you just get, the result. And the result will be, it's a match or it's not a match. The result will be just a Boolean. Does this phone number belong to you or not? Does the phone number that you selected in the beginning, is it the same phone number of this mobile data session or not? Sorry. So what is the user experience? Maybe this will make it more easy to understand. So when a service provider, such as a bank, a retailer, or a travel provider, deploys this product called Number Verify, it means that their customer will enter their details when they first register the app, I mean the phone number. And then when the customer completes a transaction on the app, at this point, the service provider can do a quick check just to match the phone number mobile number in the mobile network and the number that you inputted. So this is how you authenticate the user via possession of the SIM card. So there is no more one-type PIN exchange. Once customers are already logged into their service provider's account, for instance, you can send a payment or buy a sofa, Number Verify can also authenticate the customer from the sign-up registration details, and that will be used whenever you log in. So since the phone number is already registered, the login can happen totally seamless next time. So as I said, the user never leaves the app in order to perform this transaction because it's all happening behind the scenes. Let's see here an example. So as you can see, the user won't notice as much because it all happens behind the scenes in a few seconds between the app, the service provider, and your mobile network. What about dual SIM phones? Dual SIM phones are, of course, supported, just like any other mobile device with a SIM card, right? However, the user must use the correct mobile phone number linked to the SIM card that they're using for mobile data browsing. So this same number will benefit from Number Verify for all supported service providers. What if you still consider that SMS OTP authentication is the right way for your app? You can add on top of that, you can add an extra layer of security. So to give you here an example, you can use a SIM check product. So with SIM check, you can indicate whether or not a SIM card associated with a mobile phone number was changed within the last 7 days. Actually, this check can be used to detect attempted SIM swap fraud, and it can be used to augment any existing 2FA or anti-fraud workflows. Making this request is super simple. You just create a True ID object, and then you just check if supports SIM check, and then you just have the results, true or false. Has the SIM been changed in the last 7 days or not? Okay, so just a final note on financial apps, because we talked about a bunch of authentication methods, but actually the use case of your application is very important here. So what if you're using SMS OTP in banking or financial apps? So by relying on the SIM cards, you outsource the security processes to telcos, right? They have no contractual obligation to have their processes right. And as a result, telcos may issue replacement SIM cards to fraudster due to insufficient identity checks. And this does happen. And then you have Android platform features, because as you all know, Android is a very open platform with many features that can be potentially misused. So for example, if you ever heard of banker malware, so banker malware can read the contents of the SMS via accessibility services intended for people with vision impairment. So malicious applications can also intercept SMS messages through SMS reading permissions, but they can also hide directly behind the SMS messenger apps. And this is a successful tactic of the Joker malware that's often found on Google Play. actually the telco infrastructure is insecure because the technological product behind SMS is antique, as well as the infrastructure that runs it. So messages may travel through the cellular network unencrypted, and they may be stored unencrypted in the telco databases or logs. But also, the important data is hidden in plain text, which means text in SMS messages is not formatted. And hence, recognizing the important data is complicated. The user may be susceptible to phishing attacks by just blindly rewriting the codes in the SMS into a phishing site, accidentally approving of incorrect operations. So I see that this year there was a bit of interest around phone number authentication. And there is a talk right after this, I think, by Paul on how to authenticate also with non-Google identities. And also yesterday, Christian talked about passwordless authentication with WebAuthn, which was also super interesting. So I suggest you check that out too if you're interested in this topic. And there you have it. Thank you so much for listening to me.